Good morning, students. Welcome to the chemistry class. Today we are going to complete physical chemical change, elements, compounds, and mixtures. Let's start with this topic of purification of water. In cities, drinking water is supplied from waterworks. In this flow diagram, you can observe it very carefully, right? So, um if I want to explain this diagram, okay, so in reservoir, okay, so this reservoir may be lake water or dam water. From that reservoir, water is going to sedimentation tank. Why? Because here we are getting heterogeneous mixture, suspensions. Many particles are or impurities are get suspended in the reservoirs. So in first tank, sedimentation is done, right? So naturally heavy particles they get settled down due to gravity. So this is first sedimentation tank. Now next another sedimentation tank. Now here the particles which are light, okay, those particles are forcefully suspended in this tank, right? Because they are light, so they will get floated in this water. But by applying external pressure, by increasing the gravitational force, we can sediment these light particles. Now next, filtration tank. In filtration tank, particles or the water, it's getting filtrated. That water is passing through different layers of stones, fine stones, then coarse stones, and big size stones. So through this filtration tank, water is passing through this chlorination tank. Now in chlorination tank, chlorine is added, or we can say bleaching powder is the source of chlorine. So when we put bleaching powder, chlorine comes out, and this chlorine is a disinfectant. It is used as a disinfectant, and therefore it kills all the microorganisms or bacteria present in this tank, and then it is used by whole city. Okay. Next, physical change and chemical change. Okay children, here I have shown you two diagrams. In first diagram, in physical change, you can see evaporation of water, and in second diagram, this is hydrolysis. In evaporation, simply we are heating water, right? So water is changing from liquid state to vapor state. And in chemical change, this is hydrolysis. By using chemical energy, by using electrical energy, here water is decomposed into hydrogen gas and oxygen gas. Now by looking at these two examples, we can say in physical change, no new substance is formed. Why? Because liquid water to gaseous water, right? Here there is only change in a state, okay, change in a state of water from liquid to vapor state. So we have not got new substance, right? H2O, there is no change in our formula, and it is reversible. So these water vapors can be condensed back. So physical change is reversible and there is no new substance, right? In case of chemical change, yes, see this is hydrolysis, splitting of water with the help of electrical energy. So we are getting new substances, that is hydrogen gas and oxygen gas, and it is irreversible process. Okay, so H2 and O2, these two gases need to combine chemically, and then only we'll be getting water back, water, right? So by using simple techniques of physical testing, we cannot convert H2 and O2 into water, right? So in physical change, no new substance is formed. In chemical change, new substances with new properties, right? Why new properties? Now see, water is a fire extinguisher, but hydrogen is used as fuel. Oxygen supports combustion, right? So properties are new because of the formation of new substance. Physical change is reversible and chemical change is non-reversible. Okay children? Okay, what are the examples of physical changes? Melting of wax, dissolution of salt in water, glowing of bulb, evaporation, just now we have discussed, then mixing of iron filings and sulfur. These are examples of physical changes. And for chemical changes, rusting of iron, yes, it cannot be reversible, it is irreversible rusting of iron, or the formation of iron sulfide from iron and sulfur, or burning of magnesium rubbon in presence of air to form magnesium oxide and magnesium nitride. So these are chemical changes. Okay children, let's see classification of matter on the basis of chemical composition, right? So classifying the matter by its chemical constituents as an element, compound and mixture. So we will discuss one by one. Now see elements. So element is basic form of matter that cannot be broken down into simpler substances by chemical reactions. Elements are building blocks of various types of substances like common salt, proteins, carbohydrates, fats. All these substances are made up of limited set of elements. They are pure substances. They contain only one kind of atoms. They cannot be broken down into simpler substances. Okay, so 115 elements are known till today. Many more are being invented. Some of these are hydrogen, nitrogen, iron, gold, oxygen, platinum, phosphorus. Okay, and 92 elements occur in nature while remaining 23 are prepared by artificial radioactivity. They are also called man-made elements or synthetic elements. Every substance is made up of one or more elements. Diamond and graphite are allotropes or different forms of carbon, which is also an element. You must have seen periodic table. There you can observe all these elements, their symbolic forms. So elements can exist in all three physical states: solid, liquid or gaseous. Most of the elements are solids, others are gases and few of them are liquids. For example, sodium, potassium, calcium, iron, aluminium are solids. Mercury and bromine are liquids, whereas hydrogen, oxygen, fluorine, nitrogen, chlorine, helium, neon, these are gases at room temperature. 11 elements are gases and only 2 elements are liquid at room temperature. Gallium is low melting solid and it becomes liquid at 303 Kelvin. Okay, let's start classification of these elements. Before classification, I'll tell you, as 26 letters of English alphabets form a large number of words. Just like this, elements combine in different ways to produce extremely large number of materials and compounds. So all these elements can be classified into three groups: metals, non-metals and metalloids. So what are the metals? These are electropositive, okay, can lose electrons easily and form positive ions. Most of them are malleable and ductile. They are good conductors of heat and electricity. Okay, copper, zinc, aluminium, gold, silver, tin, lead, these all are metals. All metals are solids except mercury, which is liquid at room temperature. Okay children, now non-metals. So what are nonmetals? An element which can gain electron to form negative ions are called nonmetals. They are neither malleable nor ductile. They do not conduct electricity. Carbon, boron, sulfur, phosphorus, oxygen, nitrogen, these are nonmetals. Now, what are the metals? See, they can lose electrons and form positive ions. They are malleable and ductile. They are good conductors of heat and electricity and mostly they are hard. They have high melting and boiling points and sonorous. And what are non-metals? They can gain electrons and form negative ions. They are non-malleable, non-ductile, do not conduct heat and electricity and mostly they are soft. And generally they have low melting and boiling points and they are non-sonorous. That's the difference between metals and non-metals. Now what are the metalloids? Yes, there are few elements which resemble with both metals and non-metals. They are called metalloids. They show the properties of metals as well as non-metals. They are also called semi-metals. Okay, examples are boron, silicon, then germanium, arsenic, okay, antimony, tellurium, etc. Okay, our list, next after elements, what comes? Compounds. So a compound, this compounds, okay. So a compound is a substance made up of two or more elements chemically combined with one another in fixed ratio. Okay. So compounds are pure substances, have a fixed melting and boiling points. Okay. Compound contains same kind of molecules and its formation involves changes in energy. A pure compound, whatever may be its source, always contain definite or constant proportion of elements by mass. For example, water contains hydrogen and oxygen in the ratio of 1 is to 8 by mass. Its components cannot be obtained by physical method. For example, iron sulfide cannot be broken down into iron and sulfur by any physical method. It is homogeneous and has same composition throughout. It can be represented by a chemical formula. See, water H2O, iron sulfide FeS. Yes, so chemical formula is there. And its properties are different from its components. For example, water is a compound H2O, and H2O properties of water are totally different from hydrogen and oxygen. Let's see mixtures. A mixture contains more than one elements or compounds which are not in fixed ratio. They consist of more than one kind of pure form of matter known as substance. A substance cannot be separated into other kinds of matter by any physical method. Sodium chloride dissolved in water can be obtained by distillation or evaporation. However, sodium chloride itself is a substance which cannot be separated by physical process into constituting elements. Sugar is a substance because it contains one pure kind of matter and its composition is same throughout. Soft drink and soil are mixtures. Thus, mixture contains more than one substance. Let's summarize a difference between or differences between compound and mixtures. Now see, in this diagram you can see elements, compounds and mixtures, right? Now hydrogen and oxygen, yes, these are elements. Why? Because these hydrogen and oxygen elements are non-breakable. Okay, then what are the compounds? Now see, in water H2O there are two elements. Which two elements? Hydrogen and oxygen, right? And hydrogen peroxide, again we are having two elements but in different proportion. Hydrogen 2, oxygen 2, H2O2. So here this is again an example of compound but with different compositions of element, right? But what happens in mixtures? Here you can see oxygen and hydrogen, they are separate, only they are mixed together, right? So hydrogen and oxygen, they are only in the form of mixtures. They can be separated easily. But in case of compounds like water, it is very difficult to separate hydrogen and oxygen from the bonding which is formed in these compounds. Okay, children? Okay, so what is the difference or what are the differences? See, compound is made up of elements combined in fixed proportion, and the mixtures, in mixtures the components of mixtures are in any ratio. Compound is always homogeneous and mixtures can be homogeneous as well as heterogeneous. Properties of compound different from properties of its components, and properties of a mixture are the average properties of its components. The components of a compound cannot be separated by simple physical methods. The components of mixture can be separated by physical methods. Heat, light or electricity is either produced or absorbed during formation of a compound. No heat, light or electricity is absorbed or evolved in preparation of mixture. A compound is represented by chemical formula and a mixture cannot be represented by a formula. A compound has fixed melting point and boiling point, and a mixture does not have fixed melting point and boiling point. So here we have completed our lesson number 2 Is matter around us pure? Thank you so much.